Okay. Right. Okay. So today's topic is about access control technologies. Now, this is a cornerstone of cybersecurity. As much as we have looked into the CIA concepts, security control framework, we also looked into risk management. We also looked into cryptography, which is another very important aspect of cybersecurity. Um, and then we looked into software security in the form of web application security. And finally, we have come to wrap things up in the access control and security technologies. Okay, so the learning outcomes of this module is that we'll understand how access control systems work and how identity is managed through those kind of access control techniques, analyze different theoretical security models, and then we discuss about security technologies such as the different kinds of security technologies we'll be looking at, including firewalls, VPNs, intrusion detection prevention systems, and so on. And we'll be referring to this book primarily as we did with several other modules before. So the content of your LMS is also basically built around this. In some cases, as we'll soon see in the slides, some of the details may not be available on the LMS directly, but on the reference given below. If you go to that link and read that chapter, you'll find more details on, especially on the access control techniques like role-based access control, discretionary access control. There's not a whole lot of details on the LMS as text, but the reference material as well as the slides covers most of these aspects. Okay, so good question. Where possible, the links, especially I also mentioned in OWASP when I was covering OWASP, and there was a link to the main content on the OWASP website. That reference material is not ignorable. You need to read those materials. In other cases where, sometimes it's already mentioned it's optional, or if you want to read more further reading, then you can read those. But in some cases, especially in the cases that I have shown those, and today I'm telling you, although I'll not be able to show you because I'm not on the LMS now, is basically the description of the access control techniques, the MAC, the discretionary access control, and so on. These are not covered in detail on the LMS as text, but the reference, which is basically chapter 14 of this book, if you go there, it's all described very nicely. And also you can look up these PowerPoint presentation slides and the video. Okay. So these are the kind of access controls, and we have been introduced to this concept before. There's a physical access control, there's a logical and technical access control, and the administrative access control, right? We are all aware of this. Does anyone have any doubt? Because I think this is something we've already studied. Can anyone say an example of a logical technical control? Let me just, sorry, yeah, password, correct. So password or enforcing a password regime, multi-factor authentication, these are all logical and technical controls. And firewalls, VPNs, basically most of the technologies we'll be looking at today from a practical perspective are forms of logical and technical controls. However, both the physical controls as well as the administrative controls, although they are limited in the variety of things, but they're equally important because not paying attention to either one of these controls may lead to substantial breaches in your organization. So we need to pay attention to all of them, preferably under an overall framework. This is just is categorization. Under an overall umbrella would be something like a NIST CSF or any other kind of framework. Okay, so today's important lesson is basically on access control strategies, correct? And those of you who have been in the IT industry long enough, or you have worked in databases or something similar to network security or system administration, should probably be already familiar with some of these concepts. So, for example, the first one is the role-based access control. So, role-based access control implies that instead of assigning permissions directly to a user, we give permissions to a role of a user and assign a user to the role. Okay, so it's best understood. For example, we looked into some instances when I was showing you the LMS. I could show you that I have been logged in as an instructor or tutor, and then I have a separate, I have a different view than a student. But if I wanted to also have a student view, then I quickly click on a link, an option which says that view the LMS as a student, and then I'm temporarily moved into the group of students. So on that particular realm, or on that particular LMS, I will be viewing everything as a student, and I wouldn't be able to see anything as an instructor unless I revert back my role. So this is an example of a role-based access control. Similar to this, you have in Unix or in Windows operating systems, you have examples of different roles. System administrator is a kind of role. Normal user is another kind of role. But even other than this, there are also different kinds of other roles. For example, you could find in some systems there are web administration roles, database administrator roles. And why are these roles created? These roles are created so that certain types of access rights pertaining to different kinds of systems and databases or files or directories are assigned to anyone who is assuming this role. And this makes management of user access control much, much easier, right? Now, how do we know what should be the role of a network user or a system user? Generally speaking, as I said, in an organization, roles of employees or personnel are clearly defined. And for example, you can look into the hiring PD of a person, an employee, and find out what the role is, right? Maybe they're a lecturer, maybe they're a university administrator, maybe they're security personnel within the university, and they have specific roles. Based on those roles, you identify what kind of systems and information do these roles need to have access, and what level of access do they need. So anytime when you join as an employee, then that employee's role is assigned to you, and therefore you keep working with the rights and privileges of that role. Now, discretionary access control is a little bit different. This is basically someone creates something and they become the owner of that something. Or in the most simplistic case, everyone is the owner of the system that they have logged in. From this point, anything that they create, they can then assign that object or so that creation, whether it's a file directory or anything else, they can assign it to someone else. So this is called discretionary access control, meaning the owner has a right of assigning access to others. Okay. The third one, the mandatory access control, is a very restrictive form of access control where there is a single entity or a body which governs the whole access control system. And they assign an individual with their level of access, let's say top secret, secret, classified, and so on. And also, these people with this level of access can only have access to those resources that are at that level and beyond and below. So this is a kind of centrally administered access control mechanism, and it's very strict. And we'll be going through the pros and cons of each very shortly. The fourth one is permissions-based access control. So it's normally known as rule-based access control, but sometimes people get confused when you shorten the rule-based access control. It sounds much like the role-based access control, which is also starts with an R. So either we capitalize all the starting letters and call it RBAC, like role-based access control, or we just capitalize the remaining part after the capital R, and then we call it rule-based access control or permission-based access control. So permission-based access control is similar to role-based access control, but it has a higher level of granularity, in terms of what kind of access they do have. And access are often listed as rules. So every group or ownership will have a set of rules assigned to these groups. And that's how you can think about this as a more refined version of role-based access control. You can have more fine granular control over what someone can do with what. Okay, so as I mentioned before, here we talk more about the role-based access control. And systems that employ role-based access controls define, now you come to know about two things, right? One is basically a subject. Subject is a user entity. And the other one is an object. Object is the file or system that they are working on. The subject works upon an object. Now, in this case, this role-based access control is often implemented using groups. And an example could be a bank may have loan officers, tellers, bank managers, and clients, right? And then when someone is coming into the system, you assign them into one of these groups. And if the organization hires a new loan officer, so the new loan officer and the old loan officer will share the same access rights. Okay. Now, that's because when you're doing things, they will look into whether you have the rights as a loan officer or not. But the question is, does it mean that whatever this person does, you will not be able to distinguish or differentiate between the other loan officer? No, because there will be individual accounting of tasks or things that they have done. But in terms of access rights, they will have the same access rights. And this helps a lot because if one of the loan officer is not working because they're unwell, maybe the other loan officer can fill in. And depending on whether they have user level access rights pertaining to the same clients, they may be able to see, both of them may be able to see the same client. Okay. Okay, so what are some of the advantages of role-based access control? Number one, it's very easy to use and implement, right? Easy to administer. When someone leaves a job, we just need to remove them from that role, and then they don't have those rights anymore, right? Maybe they'll be a guest, or maybe they were a normal user and some things like that, provided that's also another default group. And it's also built into most frameworks. So most databases will have role-based access controls and so on. And it aligns very nicely with the principles like segregation of duties, principles of least privileges. Remember those principles we discussed in the first module? we call them security design concepts, right? The kind of concepts that you apply when you're designing a system or analyzing a system security. So the principles align very nicely with segregation of duties because one role is not doing the work of another role. And the least privileges is also ascertained, provided that the system administrator has defined the roles meticulously so that once someone is in a role, they are not allowed to do or assume another role, right? And I think we discussed this kind of things before. We talked about a CEO of a company demanding to be, getting the rights and privileges of a system administrator, and we said whether they should be able to get it or not. So we mentioned it's not possible to do that because of violating the segregation of duties and also for the least privileges, right? So, for example, if the CEO of a company has both the belongs to both of these groups, CEO or more generally speaking, board of directors or C-level executive, as well as system administrator, then whenever they're doing one of their tasks as CEO, maybe they actually inadvertently use the rights of a CSAD, and that's not desirable. And this also opens up avenues of attack. Someone can attack the CEO, and if they compromise the role of a CEO, they also become a system administrator automatically. So that's very, very dangerous. So one of the issues of the role-based access control, issues when I say issues of problems, right, is number one, documenting the roles and accesses is a bit tedious, but it needs to be done. In case of multi-tenancy, that means you want to have two different kind of someone belonging to two different organizations is also very problematic if both of these organizations share some common information. There is a tendency of scope creep. Now, this is the most important problem of role-based access control. This is called scope creep. So let's say someone gets a role, and then they don't leave that role. They get assigned to different roles. So that means now they have visibility of different parts, and not just visibility, different access rights of different parts of the system. And that makes managing this role much more difficult and much less accountable. So scope creep is basically a problem of the vanilla role-based access control model that we have discussed, okay? And it also doesn't support fine-grained control like data-based access control, where, okay, this role can be a loan officer, but they can only look at the subset of clients, not everyone. It's difficult to employ vanilla rollback access control using that kind of scenario, in that kind of scenario. So, oops. Zaid, good question. With the audio, let me see. Let me see if I can make it any better. How about now? Most of you are saying, okay, all right, that's good. Thank you, thank you. Yeah, before some of the previous comments go out of the, look, I'll just come back to those. Just remind me if there's any question that I haven't answered. Okay. Right, so the areas of caution when you're using role-based access controls are that roles must only be transferred or delegated using strict sign-off. So once I become a student, I strictly, temporarily lose all of my rights as a tutor. Therefore, I don't accidentally mess up things. When a user changes their role to another one, the administrator must make sure that the earlier access is revoked. So same concept, right? So if you've got multiple roles, then make sure that the other role is temporarily on hold until you revoke this role. And assurance for rollback access control must be carried out using strict access control reviews. So That means, this is very important, you need to periodically revisit, review who has what roles and whether those access rights pertaining to those roles are still meaningful or practical. Sometimes, someone started off with a large set of rules, but then the organization moved into a different framework. Maybe they have divided that department into two departments, and then they have slightly different roles. So you need to adapt to the situation, review the roles and who still belongs to those roles, and then curtail those roles or the users accordingly. Lone has a question. If a person is both a student and a teacher, will they need to two accounts to log in? Okay, so it can be implemented in two different ways. You can have two different identity assigned to two different roles. But here, what we're talking about is a same person or identity assigned to two different roles. So that means it will be a single sign-on, like in my case, which I've shown you previously, logging on as an instructor. But then there is a way to temporarily downgrade to the access rights of a student so that I don't get to see everything, but I focus on how it looks as a student. Okay. Okay, next comes discretionary access control. So in discretionary access control, as I mentioned before, it's a system. Wei Zhang, I'm just mentioning vanilla as an adjective, saying that it's a regular access. There is no modified version of role-based access control. We are just looking at role-based access control in the general sense, because we'll soon see when we look into task-based or rule-based access control. They're very similar to role-based control, but some additional features or additional characteristics that differentiates it from the vanilla one. You don't have to use the word vanilla. It's just me trying to explain things. Okay, so discretionary access control, as I mentioned before, is a system that employs people's or owners' discretion of the objects that they own. If they're the creator or owner or manager of data, then they can basically they're the data custodian of an object, and they can basically transfer the rights, they can share the rights with others. In Unix, this is very nicely shown as three sets of permissions. User level permission is the first set of permission. There are three letters pertaining to read, write, and execute, RWX. Then there's group level permission. You have got three rights, three kinds of access rights: read, write, and execute. And then there is a third level of access rights for an object, which is for everyone else. So basically three levels, right? User's own right to access something. Then comes the group that the user belongs to, whether it's student or teachers and so on. What kind of access right do they have for a particular file or directory or an object? And then finally, everyone else. So imagine that you have a printer, right? Printer is associated with your network, and then when you log into Kali Linux or a Unix machine, that printer will show as like a file. You can actually cat something out to that file, and it will actually print out. That's the beauty of Unix, because Unix treats everything as a file. A directory is a file, a process output of the process is a file, and devices are also files. Everything is arranged as files. Now, so that means you can think about this printer has been assigned some access rights, right? So if you're the owner of the printer, then presumably the system administrator, because this device is going to be integrated in the system, that means it needs system level permission. Then what will happen is the system administrator needs to define what kind of access rights different kinds of people will have on this printer. Number one, the printer has, let's say, 3 types of attributes, right? Read, write, and execute. So what would read mean from a printer? I'm not sure what read would mean from a printer. Perhaps it will just read the data that has been sent on the printer. Okay. Another kind of access could be execute. Execute would be actually printing, right? And write would probably be, sending a file to that printer. I'm just making things up to explain to you what would be the appropriate access right of different types of people. So out of all these three things, maybe the write is actually writing the configuration on the printer, right? So maybe that should be only dedicated for administrators of that printer, of that machine, of the network. Normal users will only have execute. That means they can send a file and get the file printed. Administrator group can have access as that, and normal users, maybe there is some accountability for not every user in the system should be able to use a printer. In that case, the user can only see, that means read from a printer, the stats of the printer, but they cannot write or they cannot execute, that means print a file. So if I could explain this, so that means the way that string of permission would look like in an access control list, such as the one that I've just mentioned, discretion in this kind of case, is basically for the user, it's the person who is using it. If they're a regular user, they can only read, no write, that means that's a gap, and then execute, that means they can print. For a system administrator, it's all of them, read, write, and execute. And for everyone else, it should be only read, no write, and no execute. Okay, so in this way, in discretionary access control, you can actually, for example, the system administrator is the owner of this object, right? Now they can assign these privileges to different groups of entities. They can actually even change how the object will be accessed by different groups of people. Okay, so that part is discretionary. And I gave you an example of a system level object, but it equally applies to a user level object. For example, you are a normal user in a system and you create a file. Then it's up to you who you want to share it with. You can make that file readable only by you and no one else. Okay, not even any other user in the group or everyone else. It's only readable by you. On the other hand, you can make it readable by you or readable within your group. Maybe students, other students, or a teacher can assign it to other teachers, but they will not make it executable. That means if it's an executable file, they will not be able to execute it or run it, or they cannot write to it. You can actually block the access to the write access of that file. So they can only read it, read only. They cannot write anything or change or modify it. This is how access control preserves the rights and privileges of users or subjects on the objects. Yeah, so Adam mentioned about SharePoint or sharing from Google. In your Google Drive or Microsoft OneDrive, you create a file, and then how do you share it, right? You can choose to share it with different people. So this is a discretionary access control. Is an example of discretionary access control. Thanks, Adam. Okay. So the advantages of discretionary access control is that there is very little sort of oversight. Everyone manages their own data, and it's very easy. It's easy to use, easy to administer, aligns to the the principle of least privilege, as long as the owner of that file knows how to responsibly share this. Because if you look into the problems encountered just mentioned below, it says that documentation of the roles and accesses has to be maintained stringently, multi-tenancy. So blah, blah. But the most important thing is that you have no central control or knowledge of who has access to what level of information. So it's a nightmare for very sensitive organizations that would like to limit the exposure of confidential documents. That's why they need to use mandatory access control, which we'll be talking about later. But if you allow people to use discretionary access control in a very sensitive environment, I want you to imagine what will happen. They can give access to anyone, right? They can create a file full of top level information and they can share it to anyone, thereby breaching the requirements of confidentiality and integrity and so on. Okay, so this is a danger of discretionary access control, that we do not know the level or extent of access that has been propagated through this. So for example, you may trust someone, right? And you can share your file with them, but you don't know if they're going to trust someone else as well and share that information. Like the Chinese whisper, they keep on, passing on the information from one person to the other. And this is something you cannot control under the discretionary system. Is that clear to everyone? So trust boundaries is quite delicate, and that's why discretionary access control is almost never used in an isolated manner. Maybe it's tied up with role-based access control and discretionary access control, or more granular rule-based access control that we'll be looking at very shortly. Okay, so what's the difference between role-based access control and discretionary access control? And there is also another, as I said before, there are variations of role-based access control, right? That's the reason I said vanilla role-based access control. There's a variation of role-based access control, which is known as task-based access control. So it's very similar to role-based access control, but the difference is instead of assigning a user to a very large role and assuming what that role does, we clearly articulate what are the tasks that are carried out by that role. A task could be printing, a task could be accessing a database. So it's a statement, right? And therefore, from that statement, we interpret what the roles actually do. So it's essentially similar. So what are the differences? So for role-based access control and DAC, they both use groups to organize users, but differ in how the groups and users deployed and used. For example, in DAC, owners determine who has access. In RBAC, the administrators determine who has access to what. And when we talk about the variation of RBAC to TBAC, this is something that might come across. That's why we're just mentioning it here. Here, the difference is that users are assigned to an array of tasks instead of roles, and tasks can vary according to user's role. Of course, the task can also vary. So maybe you have a teacher that has some specific tasks assigned to them, which are not assigned to other teachers. Maybe they're moderators. Now, of course, the argument is you could actually create a new role out of it, right? You can create a new role of moderator and assign this specific tutor in that moderator group. But this is just a workaround of creating too many roles. It's called role explosion. So if you just try to create too many roles, there will be a lot of overlaps between the roles, and thereby it's much more difficult to maintain. So task-based access control, which is a variation of the RBAC, would help you create those subtle variations in assumed roles or responsibilities of different people. Okay, now we come to the mandatory access control. Now going back to a previous comment, I believe the comment was that this is the second time you're hearing about a MAC, right? Previously, can anyone recall when was a MAC used? When was a MAC used? Yes, networking. Actually, not even networking. We use it in cryptography. When we talked about
Is it authentic
Okay,
control?
yeah. In network, there is another MAC. Okay, so now we have got three different MACs. In the network, the MAC we have learned in network is called medium access control, which is layer 2 of the OSI layers, right? Medium access control. In cryptography, the MAC that we encountered is message authentication protocol, right? Often called as hash MAC or HMAC, but that's also a MAC. So it's easy to get confused when people just use the acronym without giving it a context. So in the context of access control, it's called mandatory access control, also a MAC. All right. So in mandatory access control, everything is top down. The labels of users, and the labels of the information system are all top down, clearly laid out, and any change would require an administrator to approve that change and manually do it or automatically do it. Without this, role changes cannot happen. Okay? Does it make sense? Okay, so in mandatory access control, we ensure that the enforcement of organizational security policies, we have a security policy, and then we've got levels of sensitivity. We've got top secret, classified, sensitive, but unclassified and unclassified, whatever that classification system is. And then you assign a subject to each role and an object to each role, each object to one of these categories.
So sorry. So how is this different from role-based? Because I guess could you
Oh,
use the
okay.
labels as roles?
Uh, it's similar to role-based access control in the manner that the system administrator is the person who assigns an individual to roles, correct? But it differs in the methodology. So while in role-based access control, someone belonging to the same role will have access to sort of there's no label of the objects. There's no label of the objects. It's only labeled based on who those people are, what they're doing. That's it. So in mandatory access control, everything is articulated in terms of labels. So if you have a secret level clearance, you will be able to see secret level information that's classified as secret and below. That's the difference with RBAC. You cannot use RBAC to do that. That can be only done through mandatory access control. Is that clear?
No, not really. Sorry. Because I guess in your example, couldn't you just have the roles of like secret and top secret instead as well?
Okay, that's a good question. So can we create a role of secret and then only assign people to secret, right?
Yeah.
Then how do you create, because roles define actions, not objects. How can I define roles for informations? It doesn't make
All
sense.
right. So you mean okay. So the mandatory access is for objects then, you mean?
Exactly. It's for both subjects as well as objects. So here you can see the advantage of this methodology is that access to an object is based on the sensitivity of the object, right? And access based on the need to know is strictly adhered to. So it's one of the other advantages, that need to know is absolutely need to know basis. It also guarantees segregation of duties because some of the top secret materials can only be handled by top secret. However, having said that, top secret also has access to lower kind of information, right? So it's not strictly in a sense that they cannot view other things. In role-based access control, that can be guaranteed. Any particular role cannot see as other things. So yes, while you're right that yes, you can assign roles based on sensitivity of those tasks, but we cannot do the same for objects. That's the issue. Now, application of this obviously is very challenging, right? It's expensive to implement. So imagine you have a system of millions of files. You have to, sift through all of these files to figure out the sensitivity of each of these objects. And you may not get the balance right. What would happen if you assign every object as top secret? Basically, you cannot get the job done because lower level employees will not have access to it. What would happen if you give everything access at the lower level, unclassified? Then everyone can do the job, except the confidentiality will not be maintained, right? So this is how there's actually a balance of finding out who does what. The last one is basically a kind of a hybrid system, which combines the rule-based access control with, this is actually rule-based control, which combines the role-based access control with and assigns some tasks to it. So there are some rules, but the rules are basically an action on a particular object. What can you do to an object? Not just access the object, but what exactly can you do? So for example, let me see if there's an example here. There's an example. So you can imagine that there is a server class. A server class can have read access, write access, run, start access, stop access. So those of you who have learned about Unix or a system like Kali Linux, there's a command called system control, which is a privileged command where you need to type in your administrator password to run it. But a system control basically allows a user to start or stop or resume or restart a service, right? So that means for that particular system, you have a very permission-based access control. That object has some specific permissions defined and exposed to the person who is, or to the subject who is using it. They cannot use arbitrary actions on it, only some predefined and pre-exposed functions. So this is the difference between permission-based access control and let's say discretionary or role-based access controls. So if you have a document class, then that document class may have defined actions like read, write, and delete. I mentioned to you about the file system of Unix. A server class maybe define start, stop, and reboot, and so on. So permission-based is very granular. Not only can you assign someone to a role, but you can also assign what specific objects they have access to, and what are they allowed to do to those objects. So this is more like an access control list. Like, for example, a firewall has access control list. So this is the firewall is kind of like a permission-based access control. Lone, you asked Mac sounds similar to rule-based. No, it's not. Mac doesn't define the rules. Mac just provides an opportunity for specific access holders to access specific types of documents. But permission-based is more finely granular. So every object will have a set of permissions assigned to it. And then those permissions can be exposed to the user roles. So then you can have a hybrid system. You can not only have a role-based access control, but you also have some permissions associated with each of the tasks that they do. So this is a more versatile access control. And as usual, if you have any questions beyond what we have discussed, please go to this, look up chapter 14. The page numbers may be a bit off because this may not be the exact one, but go through that chapter 14 and read up the contents on the MAC, the DAC, the RBAC, and the permission-based access control. Okay, Now we'll be looking into more confusing and perhaps a little bit entertaining models. So these are not really practical. The first two of them that we're going to discuss is a theoretical model or conceptual model to emphasize what is important in terms of access control. Okay. So the first of them is called the Bell-LaPadula confidentiality model. So this is a confidentiality model. So that means it ensures confidentiality, not integrity. Okay. So the Bell-LaPadula model is concerned with keeping sensitive data secure. And it's an older US Department of Defense model that's very inflexible and formal. And it's based on a computer science concept called state transition model. Anyway, so it implements the first of all, this is an example of MAC, right? How MAC was derived, or mandatory access control. So there are some strict layers. You can have a piece of secret data. You can have users with top secret clearance who can access those data, right? And so with this model, all of the objects must be labeled from the most sensitive to the least sensitive. And we divide our systems into users and label objects. And it's important that all the objects have a label for the system to work properly. So that's very important, as I mentioned, for any MAC-based system. But what's interesting here is there are some properties of this model. The property, which is simple property, the simple property says users at a certain level can only read from their level and the levels below them. They cannot read from the higher level. So this is very clearly understood, right? If you have a classified clearance, you cannot access secret or top secret documents, correct? So that's very easy to understand. Yeah. Okay. Now, it also has a star property. Okay. It just mentions that it can be applied a little bit more strictly. So the star property prevents anyone from writing down to a lower level below them. Why does it prevent writing down, but it allows writing up? So what I mentioned to you before, reading from the same level and below is still applicable here. But on top of that, there is a stronger property that you will only be able to write at your level and at the higher levels, but you cannot write to a lower level. So this is where it might be counterintuitive to you, many of you. How can you, if you're basically classified, how can you write to a secret or top secret level? But why does it allow you to write to a higher level? To limit transfer of higher sensitive data to a lower level. Yes. So the first thing is, it's very easy to understand. If you write to a lower level, then you might accidentally expose some of the secrets in your level to the lower level. That's understood. But when you're writing to an upper level, they already have access to your level. So they can actually read what you're writing in your level anyway. So it's not difficult to convince that it can be written at a higher level. Remember, this is not about integrity. This is about confidentiality. Okay? So we'll be talking about the integrity a little bit later. So the third strategy or third setup is called a strong star property, even more restrictive. Someone can only write at their own level. You cannot read or write from other levels. Okay, so if you are in classified, you can only read classified materials and write into classified materials. You cannot read from other levels. Why? So do you think it's practical? Anyone? So on the face of it, it may not look practical, because if everyone is writing in their own levels, then to get things done, you'll need similar types of actions at each level. So there must be someone doing the work for you at the top secret level, someone doing the same work at the classified level, and someone doing the same work at the lower classification levels.
Could you please repeat the question? I don't think I really caught that.
Oh, I was just mentioning about the strong start property of writing, reading and writing only at the same level, the rightmost figure. I was just alluding to the practicality of this methodology.
Oh, okay, thank you. I think my internet's just
Yeah.
having a bit of a moment.
Okay, no worries. Oops, sorry. Greg, you're asking, it doesn't make sense because surely the highest level of confidentiality, user might have less sensitive content they want to share with people on lower levels. What do you mean less sensitive? I don't think that's less sensitive. Higher level of sensitive means more sensitive, right? Okay, so if that's clear, now let's dive into the other one, which is integrity model. So this integrity model is called the BIBA integrity model. Oops. Okay. So now in the previous one, we looked into confidentiality model. In here, in this one, we look into the integrity model. So it's concerned with data integrity. So what are the aspects of data integrity that you can think of? Correctness, consistency, both internal and external consistency. What else? Is there anything else, any properties that you can think of that are associated with integrity? Maybe immutability, whether it's allowed to be changed at all, right? So there are many different aspects of integrity, but we are dealing with a system which allows less contamination or affecting anything that affects the integrity. We don't allow that. And how does it work? So we have an authentication process that prevents unauthorized users from making modifications. We use mandatory access controls here too. It's just like a lattice model. And we have controls in place that are slightly different than those covered in the Bella-Padula. So here we have no write-up policy and no read-down policy. Okay? No write-up. Why is that important? Why can't we write up? We can, in this figure, the BIBA model allows you to read from above. Remember, this is not a confidentiality model. This is integrity model. We need to assume that confidentiality maintained in some other means, for example, in encryption or whatever, right? But in this case, it's more concerned with maintaining integrity of the data. And how does it do that? It doesn't allow you to write at a higher level of integrity. Remember, one thing to understand and remember for future, if you want to recollect it. Lower level of integrity simply means that the data is coarse, the data is full of errors, or it has some errors. And the higher the level you go up in terms of integrity means the data is more refined and more correct and more persistent. So that means that if you're at a lower level, you're collecting data from, let's say, one source, okay? And that source could be incorrect. So you can mention what data you have collected and what source, but that is not the final truth. Maybe at a higher level, they get to see data from two different sources. They can correlate and identify the actual truth, and then they can write that information at the level. You do not necessarily, you can have access to that level. That means you can see what that really means now, because you have collected one part. Now other people have collected the other sources, and now you can see. That's why reading is allowed for integrity, but you cannot write. Because if you write, the information you see is contaminated, and you're going to contaminate higher level information. Does it make sense? Okay, so what I'm trying to say is the higher level information here means more accurate information. As I have given you an example, at a lower level, maybe a field worker is collecting some data, right, from one particular source. And, there could be other field workers collecting that same information that will be collected and reviewed and ascertained at a higher level. They can actually fix those errors, identify those mistakes, and then establish a source of ground truth. So as the data is fixed and corrected and so on, they reach a higher level of information. Yeah, correct, Greg. So this is not based on secrecy, it's based on accuracy. Yeah. So basically here in this graphics, you can see that this is the, is that the diagram is incorrect? Why do you say the diagram is incorrect?
Because the diagram says a layer of secrecy, there are higher secrecy up there and low secrecy.
Oh, I
Which-
see.
Yeah,
Okay,
yeah.
okay.
Which does make sense because you should not
I know
the integrity
that.
of the like highly confidential data is very important. So
It's a
writing
good
up.
point.
Yeah.
This is from the book, I guess, but your explanation, I agree with your one. It should be high level of accuracy rather than secrecy, because if it's secrecy, then how do you even read from the higher level, right? But this is not something that we have invented. I think this was copied from one of those books. Yep. Good, fine. I'll probably chase it and provide some in the discussion forums, some more information about this. Okay. Now there are a few other examples of models that have practical use. So these models that we were talking about, this one, the Clark-Wilson integrity model, and so on, they're actually practically used in different places. So Clark-Wilson integrity model was introduced back in the 80s, and it has three main goals. Number one, there shouldn't be any changes done by any unauthorized subjects or unauthorized users. So this goal will ensure that only authorized entities can make authorized changes or modify the data. Second, no unauthorized changes can be made by authorized entities. So even if you are an authorized entity, you should not make a change that is inconsistent with the requirement of that piece of information. In other words, it affects the integrity of that object in a negative manner. So this is the second requirement. Next, maintenance of internal and external consistency. This goal ensures that the data remains consistent both internally within the system and externally. So this is very important, especially for financial systems and so on. So maybe let's say you are a brokering house and then you collect a lot of internal orders, and when an order is placed, let's say you have seen that this order can be executed, so you internally execute the order, satisfy the order, but then what you do is go to external source and then implement that order. Okay, that may not be possible for some reason. Maybe this external system broke, or that quantity is not available. In any case, there is temporarily an inconsistency in the status of things. So someone has already purchased this, and then it cannot be delivered. It cannot be actually recorded as a purchase because you cannot deliver it. So that means at a future point of time, you need to fix this inconsistency and make both the internal information, the external information consistent with each other. Okay? And many critical systems use it. As I said, financial institutions like banks and stock exchanges and so on. Also, medical research centers and health clinics, they all use the Clark-Winson integrity model. Okay. Zaid, if it's possible, could you email that to me? Because it's kind of difficult for me to look at it right now. Oh, you're talking about a particular document. Okay. Maybe I can provide you with the document. It looks like an IEEE document, and I can provide you with the document. Okay. Right. And the next one is Graham-Denning access control. Okay. This one is an access control that focuses on defining how subjects interact with objects. So there you have a set of objects and set of subjects and a set of rights. So very similar to the kind of concepts we had discussed before. Remember the permission-based access control? So this actually addresses three main issues, the Graham-Denning access control model. One of them is secure creation and deletion of subjects and objects. So it allows you a secure mechanism of creating or deleting both the users and the objects. You can assign access rights and define by some rules. So you have some rules that can be applied to objects, like we have seen in the permission-based access control. So this is basically an implementation of the permission-based access control, an access control mechanism for distributed systems. So it can be also extended to systems of systems, so like internet or multiple databases connected to each other. And this can be represented as node in a graph. And then this can be both internal and external access control can be maintained in this way. Okay, so some examples could be Oracle. Oracle's databases used to use Graham-Denning access control underneath. But anyway, this has been used in many different places. Again, the source is the same, but just different pages that you can go through the access control. Okay, now we come down to firewalls. So how many of you haven't heard about firewall? Raise your hand. So by this time, at the end of this course, almost every one of you have heard of a firewall. Today we'll be discussing a little bit more on the architecture of firewalls and utility of firewalls, how they're used and so on. So based on the level at which the firewall operates, it can be differentiated as categorized as network layer firewall or packet filtering firewall, application layer firewall, or even lower MAC layer firewall or media access control firewall. You see, those of you who heard about MAC, this network-based MAC is appearing here. MAC here means medium access control or media access control layer. So the lowest in the OSI is the physical layer, where like an optical cable or for wireless is space. And the data is actually transmitted through that medium. That's why it's medium. Above the physical layer is the medium access layer. And the medium access layer basically facilitates the transmission and reception of these physical signals. What does this physical signal actually mean in terms of computers or digital devices? So perhaps the optical signals are converted to binary zeros and one digital pulses, or if there is an electromagnetic signal, sinusoidal or some kind of signal, then you convert it to its digital form, right? So this layer, the media access control layer, is also associated with who can have access to this data, right? So that's the means of controlling the access. And normally, every device that is capable of communicating will have an address based on that interface. So for example, if I have a wireless device, then I have a specific wireless MAC address. If I have a LAN computer and I'm using LAN interface, then I will have a specific medium access control address. These are all unique addresses that differentiate between different wireless cards or different LAN cards. Okay, so above the medium access control is network access control. Okay, network access control specifies what type of network system the device belongs to. So for example, a switch belongs to layer 3, a network layer. A hub, which doesn't really exist anymore nowadays, would exist in layer 2, okay, the MAC layer. So the network access layer is basically have a different addressing scheme. And in case of internet, the network access layer assigns IP addresses. On top of the MAC address for the device, we have IP address that's one level above the device addressing, but that is basically used to interact with other different machines residing on different networks. So that is basically the underlying requirement of this access control mechanism, because the same device, when it's sending data to another device, may need to authenticate at different layers of the OSI. So if I am actually I have a machine and I'm trying to communicate with Google, I will first start with my application layer. The application layer could be a form that you're submitting or like a username, password, right? But before even I get the form, my computer needs to establish a network layer communication, a TCP/IP layer communication connection with the Google server. But in order to have a connection at the TCP/IP layer, my computer with the Google computer needs to have a physical layer connection. That means there must be some means for the data coming out from my computer to go all the way to Google. Now imagine, where is Google? The Google server may be in Australia, maybe in USA. But the moment I'm asking for some information, the entire TCP/IP stack is ensuring that there's a circuit level communication happening. So the circuit level, those who have studied with networking, they know there are two kinds of networking: circuit level networking and packet level networking. Either way, there needs to be a physical pathway. So that is the whole thing. Your computer is connected to your home router. Your home router is probably always connected to the ISP through the broadband network. And your ISP is connected to multiple ISPs reaching out to the Google servers. So there is a physical connection all the time, whether it's wireless or dedicated circuits. Excuse me. Now, that is the primary requirement. And that level of access you need to also have access control established and implemented at all of these layers. Okay, so the firewall, now we're talking about the firewall, right? So what's the role of the firewall? A firewall is a device that can operate at these 3 layers: the MAC layer, the application layer, and the MAC layer, the network layer, and the application layer. All 3 layers it can operate and protect your system. So a few pictures would actually help us understand. So this is an example of a packet filtering router. So packets are coming at different layers, but what we're talking about is, let's say, the MAC layer. So here you can see that there is a trusted network. This is your organization's network that you want to protect from the outside. So what happens now, if you don't have a firewall, anyone can send any data in to your computer. Okay? Anyone can send any data to your computer if there is no firewall. Okay? So once we have a firewall, we have the means of checking. Okay, so Rick is asking a question, where is it located? So in this instance, it is shown it's at the network perimeter. You have a network of computers, and at the one end, the ingress point or the egress point, sometimes it's the same point, but it could be different. You could have traffic coming in through one ISP and traffic going out through another ISP. That could happen. But the same ingress egress point is the most common form, and you can have a firewall there, sitting there. Okay. Now, the firewall can be a dedicated machine. The whole machine is firewall, or it could be part of, it could be attached to your maybe a card which is attached to your server, or it could be implemented entirely as a software. So it comes through your networking, regular networking, and then the software actually interprets the packets and then allows some packets and disallows some packet. In fact, the host-based firewall is exactly that. The host-based firewall that you can find in Windows operating system, Linux operating system, allows users to use their host as a firewall. Okay, they don't protect the network; they're just protecting their machine. Okay, so here we're looking at a network-based firewall that is looking at the packets that are coming from the outside. Once the packets are coming, you can actually match different rules. So you can say, okay, this kind of entities coming from a particular country or coming from a hacker group, we don't want this packets to come from these groups. So we just write them down in the rule and they get blocked. So these packets don't get into our network. So therefore, the remaining packets that go in, we assume that they're good packets and they're filtered packets. On the other hand, we trust our local network, so we let all the traffic out. Okay, we don't double check who is sending to who. We just let. So this is one of the ways of packet filtering. And imagine what are the characteristics. It has to be a very fast machine. The firewall needs to be very fast, because if there was no firewall, then the packet would come straight to the computer or network, right? Now this firewall is going to inspect it and then go through the list of rules and see if any of the rules matches. And based on that, decide what will happen to that packet. The packet can be either allowed to go in, or it can be dropped, or it can be rejected. That means it will be notified that we are not entertaining your packets. Okay, so that means there is a necessity by design the firewalls to be very, very fast so that you don't experience extra delay because of this mechanism. Now we look at the network-based network level firewall. So network level firewall, we will look at basically in TCP/IP, we look at the IP address, IP headers. What is the source and destination IP? Basically, who is sending this? And IPs are generally much more easily we can figure out it's a good IP or bad IP. There are databases of good IP and bad IP. Okay, so sometimes we let packets in. So by the way, in the packet filtering route, into the packet filtering mode of firewall, address is not the most important thing. The most important thing is what it contains, whether it contains any signature of an attack. The low-level packet, does it contain any signature of attack? Sometimes in previous days, they used to send spoofed MAC addresses and packets that were faulty, in a sense that these packets will not be able to be handled properly by the machines. They will be, in a continuous loop. There are many, many different attacks. That is mostly not anymore. Most of the attacks that are happening are at the network layer and application layer. So this is for detecting malformed packets and packets that or oversized packets or something like that, and we can cut them off right here. At the next higher level, and it could be the same, it could be happening in the same firewall. The lower level of the firewall looks into the packets, the MAC addresses and the MAC header, and the network layer of the firewall can look at IP addresses, source and destination IP addresses, look at the blacklisted IP addresses and ban them. But basically, they don't let those IP addresses come in. And also, you can actually see which direction it's going, and you can actually block external packets going to known bad entities. Okay, and this is one of the ways that many administrators control what type of domains or IP addresses their users can visit and then go to, and this can be controlled to some extent at the network level. So there are different kinds of configuration schemes: static rules, dynamic rules, and stateful packet inspection. There are 3 configuration options for these network layer firewalls. Static rules are basically simple, as simple as the one that we have seen before, which is basically in the packet filtering router. Dynamic rules means that you apply a rule based on the dynamic behavior of traffic. Okay, so let's say there's a continuous ping coming from an external entity. One ping is probably okay, you let it go. But if you have accumulated a large number of pings or large number of reconnaissance packets within a very short time, then you may be under a DOS attack, or that's something you don't want to entertain. And that's a dynamic behavior. Okay, so that means it has to match several rules. Several rules. So this is a more advanced kind of ruling mechanism where several things needs to be ticked off in order for that final rule to be set. And then when the final rule is set, that means the packet will be denied. And the other one is stateful packet inspection. This is normally used at the higher level firewall, which is the the application layer firewall. So here, basically, you keep track. So if an IP address is trying to get in, they may start with, for example, they may go to your web server first, then they may go to your database server, and so on. If you want to set up some rules that can identify some anomalous behavior or unwanted behavior, that can trigger some alarm or perhaps an automatic rejection, but that's done using stateful packet inspection. When a stateful packet inspection is done, the firewall maintains an internal table for any particular source or destination IP address. So it maintains what are the things that has been done and whether these constitute a breach or some kind of warning mechanism. Okay. And here is an example of the most simple firewall rules. Very, very simple. So you see one column is source IP address. Source means who is sending the packet. Destination means where is it going to. And you can see there is some XX. So normally IP addresses are 4 placeholders or 4 octets. An octet is 8 bits, and that 8 bits, binary bits, basically translate to 256 different values. So you can have 0 to 255 different values here. So for each of these. When it is XX, it means any of these values are applicable. So you're talking about, let's say, a class B network, source address. That means your entire network is class B. It has a 172.16 and any other kind of 0 to 0.0.0 to 255.255. Any source address will match against this rule. Destination could be similar, 10.10.0.0 all the way to 10.10.255.255. So it can match. What protocol? So any packet will have a particular protocol, right? It could be based on TCP, UDP, or it could be based on more specific application layer protocol. For example, HTTP, which is web protocol. SMTP is a mail protocol. FTP is a file transfer protocol. You can mention which protocol to match, and then your action. Probably your administrator has determined that this particular internal address internal address should not be allowed to talk to an external entity, all right, for any reason. The next one, 192.68.0.0 to 192.68.255. For this range of computers should not be allowed to send a HTTP request to a particular external web server, 10.10.10.25. Okay, it's just made up, but I'm just saying what it means. Oh, sorry, it will be allowed. So you are allowing this traffic. It's allowed. Okay. The last one is also an allow to an FTP server, which has an IP address of 10.10.10.10 and a specific internal source IP address of 192.168.0.1. So this one is sending a particular request, FTP request, to an external entity. The actual firewall rules are similar, but a little bit more complicated. It can have, multiple types of jump instructions. It can have, so for example, it can have a stateful inspection. So these are all complicated. Some of these things you would have tried in the, or will try in the last lab. So you probably enjoy doing those labs using firewall rules. So you can see that if you can communicate from your Kali Linux to a Metasploitable machine, and then so you can just let's say refresh the page, right? And the page will show the current page on the server. But you can apply a firewall rule and activate the rule. And the moment you activate the rule, you'll see your web page not showing anything at all. It says cannot be reached, right? So that is the effect of firewalls. So sometimes when you see these kind of things, it could be two things. One, the server that you're trying to attempt to connect to may not be available. That's always a possibility, right? The power has stripped, or there are too many services, or whatever reason, the server is not available. The other reason could be much more closer to you. Maybe your home router or your ISP router is blocking this, or your work router is blocking it. Just do not assume that because a website is not available is because the web server is actually down. Anything that can happen in the middle, and one of the places could be firewalls. Okay. Next is application layer proxy. Application layer firewall is also sometimes known as a proxy server. And you'll see in your labs, if you haven't seen it already, probably have seen it in OWASP labs. There is a application layer proxy bundled in Kali Linux known as the burp suite. The burp suite actually is a proxy server, application layer proxy. Why? It can understand application layer protocol like HTTP. You can see what's happening in your request. Okay, and you can specifically allow or disallow, or you can act as a man in the middle and change something. For example, a user is trying to get some web page, and the web page has some scripts. You can actually program your application layer proxy to disable the script. Maybe it's malicious. You know about a malicious script, and in your application layer proxy, you write down rules to detect the script, this particular script, and then the script is stripped off, and the user is getting everything else except the script, which is wonderful, right? So that's exactly what WAF, or Web Application Firewall, does. They're extremely powerful and capable tools in the hands of the proper administrator to protect their internal systems and users. All right, so application layer proxy, it's frequently installed on dedicated computers, also known as proxy service. And since proxy server is often placed in an unsecure area of network, and we'll talk about that unsecure area with the DMZ, it's exposed to higher levels of risk from untrusted networks. So anyway, so let's have a look at the MAC. We talked about MAC layer firewalls. I won't be talking much about it. It's just looking at MAC addresses and writing access control list based on MAC addresses. So MAC addresses are addresses of the devices, right? And that can be easily spoofed. So MAC layer firewalls are not really effective. Sometimes it's used in hotels and things like that to register your device's MAC address in the database and only allow you some kind of services based on your device, particular device. And there's some problems with that too. If someone's device, the MAC address fails, then they have no longer access, and the devices can easily spoof another MAC address. So it's not really a very fail-safe mechanism. Yeah. Yeah, so Prasad mentions we use Wi-Fi control access and also in OT environments. Yes, MAC addresses can be easily spoofed. You can actually spoof a MAC address. So it's not a big problem. The problem here is that we don't know what MAC address to spoof for whitelisting, and you don't know what MAC. Oh, sorry, if it's blacklisting, you probably already know that your MAC address is blacklisted. Then you want to change your MAC address, right? But for physical connection, it's very difficult. Okay, so next is hybrid firewalls. It just says that many firewalls combine all of these technologies in the same place, and the more functionalities the firewall has, the more expensive it's going to be. And the more robust it needs to be in case of failures. But it gives you more control. And now we're going to look at some firewall architectures. Okay, so firewall architecture just means that where do you situate a firewall? We started off by saying that it can be at the perimeter of your network, but we'll soon see there are different kinds of architectures of how firewalls can operate. The first of them is a single bastion host firewall. So single bastion host just means that, also known as sacrificial host, right? So that means the firewall is just a one machine, and if that machine is compromised, then your firewall falls. Your firewall is ineffective, and it's usually implemented for hobbyists or for home users as a dual homed host. You know what a dual homed host means? Host means a server or a machine. Dual means it has got two network cards. Yeah, two network cards, right? One is facing your internal network, and the other one is facing your external network, which is your ISP. So it's called dual home network. So essentially, your router is a dual homed firewall. Your own home routers is a dual homed, or it could be multi-homed routers as well if you've got multiple connections coming in. Now, this is how it looks. Just one second. So here you can see that there are two different things shown here. One is the dual homed bastion host firewall, providing network address translation to your internal network. And the other one is an external non-filtering router. So this router basically doesn't do the firewall stuff. It's just a router. Okay, so basically, when we say home router is a one in everything solution. It has a router. Router's job is basically just find out where the source and the destination, where does the packet belong, which machine does it need to go to. That's the job of a router at a network level. But usually in our home router includes firewall, includes proxy, includes everything, includes NAT, everything it includes. Okay, it does it automatically. That's why it's less of a hassle for us as users. But for a network administrator, each of these could be different components. Each of them could be separate devices on the network. The job of the network address translator is basically primarily it's used for translating a routable IP address to non-routable machine. So basically, you see the IP address that we mentioned, there are two types of IP addresses. One is known as a private IP address. The The other one is a public IP address. For example, 192.16.0.1 is an example of a private IP address. A private IP address cannot directly get involved in communication with an external or public address. So there is an intentional segregation of network IP addresses. Private IP addresses of the same type, let's say class B, class C, they can actually talk to each other. They cannot talk to an external entity. To talk to an external entity, the network address translator housed normally within a router that can help. How does it help? It maintains a table. It says, okay, 192.168.0.1 sent me a packet for Google, all right? So this router actually has a public-facing IP address. Without a public-facing IP address, you cannot send a packet. Then you need another NAT, maybe in your ISP or somewhere on the path to Google, to maintain that for you. But generally speaking, your home will have a public-facing IP address. It can be static or dynamic, doesn't matter. Meaning it's always assigned to you or changes every time your router reboots. That's a different proposition, but it will have a public-facing IP address. That public-facing IP is a one address only, okay? And all your internal machines are going to use just that one public-facing IP to communicate with different entities. Then it's a complex matter, right? Your router, sorry, that NAT router, that network address translation router job is to understand where this packet is coming from, where it's heading, and when it's coming back, it ensures it goes to the right place, not to a different place. That doesn't happen, okay? It doesn't. So if you send a request from your mobile phone, that request, the response would not come to your server or your laptop. It will always come to your mobile phone. Why? Because your IP address is fixed with relation to that network address translation. Does it make sense? So this provides a secondary mechanism of hiding the entities because the router is making sure everything is going everywhere. There is no direct connection. Okay. The second type of architecture for firewalls is a screened host architecture. So it combines both the packet filtering router with a separate dedicated firewall, such as an application proxy server. So this is where, if I show you the figure, it will be clear to you. So here, you've got this same packet filtering firewall as a single bastion host that we have shown before. But now you are adding onto it another home, right? Another kind of network interface. And then you're connecting it to an application layer firewall, which is a proxy server. The idea is external entities. Sorry, the internal entities cannot access the internal entities directly. They need to go through the application layer firewall. Application layer firewall will check whether an approved request, like a domain, or sorry, a particular website or something like that, or the content of the website that is coming to you, the application layer firewall can notice each of these and filter each of these based on the content, and then allow this through the packet filtering firewall. So the packet filtering firewall is doing its job. It's looking at the MAC addresses and the MAC payload, but those that are ticked through the MAC payload now has to go through the application layer firewall, and if things are okay, then they're sent to the trusted internal network. So it's another layer of protection. However, this also means that if this application firewall proxy fails, then probably your whole internet is disconnected, right? Your internal network is disconnected from, but you can set it up that if that firewall fails, then you can get direct access. So it can be fail safe rather than fail. Sorry, it can be it can still work while it's not as safe. You can make it work like that. There's a question from Matt. In this example, is this app layer firewall for inbound, both for inbound and outbound traffic? Both. It's looking at the packets that are coming in, going through whether there's anything wrong with it, sending it off. And then also the internal access is also going through the application of firewall. The next one is the more secured form of all these three. This is the DMZ or demilitarized zone. So essentially, you're creating a buffer not to allow traffic from either the outside or the inside, right? So it's like a demilitarized zone, and it's borrowed from the defense. This idea and the technology and the architecture is borrowed from them. And how it is done is this. Oops, where is it? So DMZ is also known as a screened subnet. Screened subnet. The subnet is basically here. Subnet is a sub network. So you have the trusted network, and there is a sub network. Sorry, you can see the DMZ. This is a sub network. And then you have the external untrusted network, internet, right? So how does it work? So it is understood that an external entity may be trying to access some outward-facing servers of yours. For example, your company's web server, right? So rather than putting the web server along with the rest of the internal network, you can put the web server on its own domain, own subdomain, and like this, and call this a demilitarized zone. And this demilitarized zone is isolated, both from the inside and from the outside. Okay, so from the inside, it actually allows certain actions only from the inside, not from the outside. So for example, configuration of the web server, it will never allow from outside the network because it's not trusted. It will probably allow from inside the network. Accessing certain types of data can be allowed through the proxy from the inside, not from the outside. So this is how this is done. But how is it done? Using two different networks and two different firewalls. One of them is the internal firewall, and the other one is external firewall. On top of that, you may also have multiple proxy servers sitting inside the demilitarized zone. This is the most secure form of network firewall configuration. Okay. Yeah. So I'm just explaining it to those who understand this concept to relate it, because if you're doing, let's say, some degrees that you have where you have pre-exposure to networking, then all of these things will make sense. Otherwise, I'm trying to break it down to something that many people will probably understand a little bit of. Okay. So this is the configuration, two different firewalls, one checking the connections going out, the other one checking the connections coming in, and there's a proxy server that's maintaining the consistency in the application layer. And please go through the references if you want to learn more. Okay, the next topic, I'm mindful we don't have much time. We'll be basically hurrying through the next topic because while this is being covered as part of your this topic, access control, this will not be accessible in the sense I will tell you what's really not accessible, and then you can figure out. So remote logins basically allow a user to be outside of their organization and then try to communicate. And there are several internal services that can facilitate that. One of the most common ones is known as the radius. This is from the times of the old modems, modulator, demodulator. If you have lived long enough, you probably remember internet access through dial-up. So your phone, your phone cable used to connect to a modem connected, which is inside your laptop or your PC, and then your machine also sends some audio signals through the phone line, through the exchange, all the way to the recipient's phone line, modem, and then the messages will be connected to each other. There used to be a specific tone. And these are all used to be done through, for an ISP, this would be done through a radius authentication process. Radius is still used, for example, in wireless networks too. The 802.11 access will be done through majority cases will be done through radius. But primarily, this is done for three reasons: for authentication, authorization, and accounting. Accounting happens at the billing section or looking at what people are doing, but the main thing is it handles both authentication and authorization. So just because you're authenticated, it doesn't mean that you can do everything, right? So that's the authorization part. Okay. So I don't know, Abdul, if you're mentioning this exam or some other exam, I can guarantee this is not this exam we're talking about. We're not talking about DSLAM switches and things like that. I'm just reminding you where this terminology originated from. Okay, so the radius, diameter, and terminal access control is out of bounds for your exam assessment. This is maybe still important for you for the quiz because quiz is open access, but not for the exam.
No, I was like, when you said it was old enough, so we
Yeah,
remember
yeah,
the US robotics forums and DSLAM switches and the
correct.
Yeah,
Yes.
yeah.
55K was one of the highest, but remember, this is not
56,
native.
yeah.
56K, it was not native. I started off with 2K boards.
Yeah, I remember
2048 boards.
the
Yeah.
26K and the Bigfoot hard drive.
Yeah. No, that's good. Good old days. Yeah. So, and then there is a slide on Kerberos ticketing. Essentially, this is how it works. Again, we are just skimming through because this will not be covered as much. For those of you who want to learn more, the reference is given there for you to learn more. But we'll be looking at from a bird's eye view of what this technology is used for. Okay, so here, as you can see, a client is trying to authenticate to a system of services. Then they first try to connect to the authentication, Kerberos authentication server. And then Kerberos authentication server looks at the username, password, and authenticates, and then provides with a ticket, just like a session ID. And this Kerberos is basically our previous form of what we know now known as federated logins or OAuths. It's a pretty previous form of these OAuths. Okay, so it just passes on that Kerberos ticket, and you maintain the ticket, and that using the ticket for as long as it lasts, you can access many of these things without authentication. Okay, so there's a lot of details. Please go through. Fortunately, we don't have the time to explain everything here. So basic differences between radius and tax hacking, you can see they're very similar, except that in TACACS, the authorization part is completely separate from authentication part. In radius, authentication and authorization happens at the same time. In TACACS, they're separate. They're separate protocols, and separate sub protocols. But yeah, don't worry. You're not going to be tested on this on the exam. Okay. Now coming to the more interesting ones, virtual private networks, VPNs, because it's a topical thing, especially for young people who are probably not with us. I mean, young at heart, but not, the age-wise, because there's restrictions for young people to get access to these social media, and many of them are using VPNs to circumvent this. Why and how? So what was the restriction for age? That children from Australia who are currently living in Australia should not be allowed to access these media providers, for example, Facebook or Instagram or things like that. I'm not too sure if Roblox is included, but things like that they won't be able to access. So under a certain age. Now, this is an age restriction, but to establish the age restriction, they also need to establish whether this individual is from Australia, because probably it's not applicable to New Zealand or not applicable to Philippines or China or some other countries. So how do they know where they're coming from, right? They look at the IP address and geolocation. So VPNs allow someone to roam the internet posing to be coming from somewhere else, right? Because your identity is tied to your IP address, what they do is VPNs allow a user to connect and then act on behalf of the user to somewhere else. So all you need to do is connect to a remote VPN that's not outside of Australia, and then pass all your communication as is as an application layer proxy. You already know the term, as an application layer proxy to the remote entities, and then you can be sort of you can access those. Okay, so but the real reason why VPN came into being is not for this privacy or escaping government rules and bans and things like that, but to offer reliable and secure communications for companies, organizations who are traveling, or multiple sites. You've got multiple sites, then you can use VPN to create a secure layer of communication, essentially turning the internet into a secure layer of communication. How does it work? So there are some, the characteristics of VPN. Please go through this. There are two modes: transport mode and tunnel mode. But essentially, what this happens is that there is a client, maybe your employee, who's trying to access your internal network from outside, right? From home, working from home. How do they do that? So your company has a VPN. It has a VPN client and a VPN server. The client is installed on your device, or you can download it and pre-configure it so that it connects to the server using your own authentication mechanism. And the server basically takes in your packets, your machine's information, and places it virtually within your network. So anything you do, you can see that you are actually within that local network. So you're part of the local network, right? And all the communication that's happening between your computer and the VPN is secured using encryption. In transport mode, the header includes information about which VPN you're communicating with and so on. And it can actually, anything that untrusted network can see where you're sending things, okay? The headers, but not the content. The content is encrypted. But this also leaves, for example, that people will not know, some people may be able to infer what's happening. So in tunnel mode, there are basically two secure VPN endpoints, one externally and one internally. So it's like you have two offices, one office in New York, one office in Sydney, and one in Melbourne, perhaps. And then in each of these, you can have a VPN server. And then you can create a tunnel between your Sydney and Melbourne. And then that means you're connecting to your the VPN server locally in your Melbourne campus. And that VPN server connects you to this Sydney VPN server. And maybe the Sydney VPN server connects you to the New York VPN server. Then if you're trying to access something from the New York VPN server, there's no way anyone can understand what you're doing, because the VPN is a concentrator. That means it concentrates many requests and sends them within a tunnel. So there is no way for anyone to figure out what an individual is doing within that network. So that way, it's safe from privacy, and also it's from confidentiality. Okay, but the real challenge is whether you can trust a VPN or not. So if you're actually buying services from a foreign VPN, or I don't know, whichever VPN, there are many VPN ads propping up because of that legislation. How much can you actually trust? How do you know that it's not being sold, or this information can be summoned on the request of government or agencies? So that's the main thing. And also even the VPN, because the VPN itself is so powerful, it has complete visibility of what you're doing, okay? So whether you can trust the VPN in the first place or not. There are certain other VPNs used by security professionals or hackers and things like Tor network, which is an onion-shaped thing, right? So there are multiple layers of security, and people sometimes use those kind of networks where the endpoints are always changing, and it's not very easy to figure out where traffic is coming from. That's how the bad guys sometimes hide in plain sight. Sometimes the bad guys get away because of this kind of VPN arrangements. Okay. And this is what I just described, so I will not go into the details. You can look at that. Now what I'm going to talk about is intrusion detection. This is very important. I think it's also important for your from the perspective of exams or quizzes and things like that. Intrusion detection systems. VPN is also important, but IDS needs some crucial understanding. So intrusion detection system is actually a control, a detective control, or a preventive control, depending on whether it's used as a preventive measure or detective measure. But what does it really do? It detects a threat. It detects something is happening, okay, in your network or system, or that's in real time, or something has previously happened, and you're digging through your logs and therefore figuring out what has happened. So can anyone give an example of intrusion detection systems?
And most modern next-G firewalls actually have IDS, IPS. What do you call it?
Okay, so that means,
as
yeah, so
part, yeah.
firewalls can be a form of intrusion detection system. Fair enough, that makes sense. How about your antivirus software? Antivirus software. They are also a kind of intrusion detection system because
at the endpoint, yeah.
it raises alarm if a malware is trying to infect, right? Or if there is a malware in your system, it can detect it. So intrusion detection system. So as you can understand, the term intrusion is very broad and encompassing, but primarily what we do is we differentiate based on two things. One is the location. Where is it located? Is it located inside your in your network? That is it looking at network level packets like your firewall or your dedicated intrusion detection systems, right? In that case, it's a network level, network-based intrusion detection system. If it's an antivirus software or Windows or Linux intrusion detection system installed on your own machine, then it's known as host-based intrusion detection system. The reason I mention this, because the technique used to detect intrusions are very different based on what type of data is collected. If you're looking at network-based data, you're looking at IP addresses, you're looking at packets. However, for encrypted packets, you can only look at headers. You can't look at the content. So you're very limited in what you can reveal about that flow. On the other hand, a host-based intrusion system, where the packets are ending, you can look at the behavior of the processes. What kind of processes are there? What is the behavior? How much uptime? What files are they accessing? What names are they using? Right? And and the other thing is, basically, you can also look at the files that contain malware. You can scan them and you can identify malware. This is host-based. So, but there is also something called, there is another distinction between intrusion detection systems. One is known as signature-based detection, and the other one is known as behavior or anomaly-based detection. And there's some distinction between these two that you need to understand. In signature-based detection, oops, no, I can't use my card. Anyway, so in signature-based detection, any phenomenon or any system that we are trying to observe, for example, if it's a file, we convert the file into a signature. What's an example of a signature of a file? Hash. So we store the hash of a file that we know is safe. Maybe the hash is actually created by Microsoft or Windows operating system or some application software or any file that you want to download and execute. There's a hash associated with it. Once you download, or from time to time, you double check you calculate the hash again of that file and compare it with the ground truth. And if they match, that's fine. That means your file is maintaining the integrity and it's safe to use. If it's not, then there's a cause of alarm. So this is called signature-based detection. And signature-based detection not only works with files, but it also works with processes. So there can be a number of different ways where you can convert a process into a signature. For example, in this protocol, they do this first, and then they do that and do that. All of this together is a signature. And normally signatures are collected for all bad behaviors, all malicious attempts. And this is known as a signature database. In case of antivirus, the database is known as virus signatures. So that means signatures of malwares that can be found by scanning files. But in case of network-based intrusion detection system, maybe the signature is based on packet information. The packet is of size this, and it includes these fields, and so on, until they have a predefined flag to identify a network-based attack. So signature-based detection can work in both network-based IDS as well as in host-based IDS. The next one is behavior-based or anomaly-based. So in this scenario, what happens is the operator, whoever is going to introduce that intrusion detection system, they study the system. Okay, we study, for example, for our organization, we can study the behavior of our organization. We look at all packets per network or all system level calls, APIs, and so on from the host. So, and also, for example, a process is using this kind of files periodically over that time, uses this much of CPU, this uses this much of RAM, and we create a profile, we create a baseline. For all of this behavior, we create a baseline. Next, during runtime, this is called the training phase. During runtime, we compare the runtime behavior of any process or for host-based detection or network-based access with this normal behavior and see if it conforms or is it far away from normal behavior. If it's far away from normal behavior, it is raised an alarm. The alarm can be a true positive or a false positive. So that means true positive means yes, this alarm is actually an attack, or it can be false positive. That means maybe the alarm was raised because the behavior is new but benign. Because when you trained your intrusion detection system using the behavior patterns of your internal users, maybe that kind of usage was not there, right? And over time, therefore, you need to retrain your behavior-based detectors to incorporate this new normal, right? This is also sometimes known as concept drift because the concept of normality changes over time. So this is, okay, now talking about the advantages and disadvantages, I've actually gone way forward. So have a look. So there are some advantages of network-based intrusion detections, disadvantages of NIDPS. There's a description of host-based IDS and advantages of host-based IDPS, disadvantage. And then we talk about the signature-based detection, anomalous detection, and so on. I just wanted to clarify that very quickly. One of the advantages of signature-based detection is that it's very quick because calculating a hash is not very time-consuming, and you can compare it if there are lots of signatures. Maybe it may take some time, but depending on the database that you're creating, it could be a order of one lookup. That means you can just look it up with one go. It's very quick. On the other hand, anomaly-based detection may take some time because to detect a certain behavior, you may need to wait for certain things to happen. So in certain kinds of behavior-based detection, it may take some time. There may be a lag. On the other hand, when we come down to the disadvantage of signature-based detection, it's very easy to understand. If a signature of an attack is not present in your database, then you simply do not detect that attack, okay? On the other hand, therefore, the signature-based detection systems cannot detect zero-day attacks. Zero-day attacks are, by definition, new attacks that your system hasn't seen before. On the other hand, the behavior-based systems work best for attacks that are new, the attacks that are very dissimilar to normal behavior, and so on. So that zero-day attacks probably could be raised as an alarm in your behavior-based system. But the problem is you need to train and retrain much often, right? So that's also a problem. The other slides are just talking about the locations of the IDS and so on. It's not quite important. So that brings us to the end of today's lecture. Let me see. Is there any other questions?
Yeah, well, actually, I was trying to discuss something like how does Netflix, for example, know that you're using a VPN? I just think it's interesting.
Well, first of all, the number of known VPNs. So Netflix is a business to protect, right? So it's in their interest to look out for all known VPNs. So the basically blacklist request coming from VPN IPs. But if those VPN IPs change, then Netflix would not have any clue what's happening.
So what is happening is that they ask you when you subscribe, what is the country that you are living? So this is important to them. So for instance, I have installed, Netflix in Greece, and it is so I bought it from here, from Australia, and it works fine in Greece with VPN or without VPN. So they take into account what it is your country of origin. So when you ask when
Yeah, but
you subscribe,
that also creates a bottleneck, because sometimes you're traveling, sometimes for a short period of time, for an extended period of time, you won't be able to enjoy Netflix or any other service providers that are specifically blocking your access. What they do nowadays, for example, Apple and things like that, they actually use a payment system, and payment systems cannot be basically faked, right? For example, your bank is known. If it's Commonwealth Bank, it belongs to Australia, right? So if you're using a Commonwealth card, then they can verify that you are actually paying from Australia. And then they will give you the access rights and privileges for Australia. They will not let you go to a plan that's much cheaper, right? Like in India or Turkey or Brazil or somewhere else. Anyway, so that's beside the point, but this is an interesting area. Okay, so Yang Wang, you're right on the money. Just 1 second.
Is there a minimum score for the exam?
Exam, no, I haven't intentionally kept a minimum score for the exam. So you have to pass overall. You don't have to specifically pass the exam. Doing well in the exam helps, of course.
Yeah, of course, yeah.
Yeah.
It's just good to know if you're going in there to know if it's
Yes.
60, 70%.
Yes.
Yeah, awesome. Thank you.
Yeah, no worries. Okay, so now, all right, so let me see if I can show you this.
That's actually one of my questions, brilliant. So if we've already passed, what happens if we don't even write the exam? Do we still pass?
Well, I cannot answer that question for you. You should attend the exam, because otherwise that would be a non-completion of a task, I believe. So you should still attend the exam, but if you end up paying, I don't know, getting a 0 and you still pass overall, technically there is nothing stopping you from passing the subject. I would discourage you from doing that, because it doesn't look good.
I'm not at all suggesting that I would do that, but my question is actually about all of this maths that's in like symmetric and asymmetric encryption and stuff. Like, if that's part of the exam, I don't really see how.
Symmetric, asymmetric, I do not think that's. Was there any maths in symmetric, asymmetric in the LMS?
Yeah, quite a bit, I think. Also, like network engineering, there's lots of maths.
Let's have a look then. Just 1 second.
How
we
about
need
some Caesar cipher?
Do we need a student card for this exam?
Sorry, say it again.
Do we need a student card? I was just reading the documentation saying.
Yes, you do. Please go through the technology test. Okay, just 1 second. So here is your.
So I've never been given a student card, so I don't know how to get one.
Yeah, me neither.
Okay, sorry, my mistake. Don't ask me this question, because I cannot answer these questions. You need to ask.
I think last time we used the ID, our Australian ID.
Yeah, you used your driver's license last time.
Sorry, not student card. You need an identity. I interpreted it as an identity. So you do need an identity, whether it's your driver's license or any form of, I don't know. I'm not a reliable person because I do not administer it. I'm nowhere, near this. I don't know how this is done. But what I'm told to tell you is that there's an exam technology page. Read this thoroughly. If you have any questions, contact your student IT support, or online, the people over here. Just one second.
Yeah.
Over here.
I have done IDPET technology test last week. Is it all right? Am I going to do it again?
Just try it again. It doesn't harm. Just how many minutes
All
does it
right,
take?
okay.
Just take
Now
the
it
test.
says I
Yeah.
have done. It's all right, Abu.
Yeah, it should be okay. But if you haven't done it, because there's some requirements of, I don't know, no second monitor or some arrangements. So you need to be aware of this. I cannot advise you
Okay.
because
Now,
it's not even administered by university. It's done by a third
okay.
party.
I
Okay.
have got three monitors. Well, did there be any problem with which monitor to use? So
Disconnect them and remove them from the room.
Yeah, I think take that. That's a good advice. 3 monitors is just too many because they will record basically they're going to record your screen, what you're doing, what you're typing, and there's another camera that's showing what you're doing so that they can make sense of, what's happening.
They will
Anyway,
monitor you
yeah.
over the camera. And also, you have to disable other monitors. Even I have a laptop and the big monitor, and when the setup finished, my laptop monitor disabled. Only the big monitor has the contents showing. So yeah. But if you have some and the pre-checking will be a lot, so they will ask you use your camera to show your room, your tables, and they will keep asking you scan, showing, and take videos, and also live. Yeah, so I think better if you can remove some additional monitor, that will be better. But I think laptop one is okay.
Okay, so coming back, I told you when I was teaching cryptography that these are not important. This is for your own understanding. So that's why I probably one part of the preparation would be to go through those videos. So asymmetric, I'm just going backwards now. You don't need that calculation. And for this one, this is also an example that was given. You'll not be tested on this one. Okay, so that's all gone. Where is it? Characteristics of a good key is a very good discussion. You should be going through that. What else?
Is this stuff that we would be tested on in graduate diploma or masters or something? Because, yeah.
Which one?
Is the maths like the stuff that we would be tested on later, like in a diploma or maybe the masters?
Oh, okay. So this is a foundation course, right? This is a foundation subject. And you go on to do other forms of cryptography included in many other subjects. So for those, maybe you have to do the maths then. But this is for the understanding. Everything that's inside is for the understanding of the concepts provided in this or introduced in this, so that this is a self-contained thing. What I'm talking about now is whether it's important for the exams perspective, but it's important for understanding the concepts and getting the skills and knowledge. That's why you're doing those labs as well. But yeah, here you see there is no maths here either, right? So I don't think in cryptography we have too many maths. There are maths, but not accessible maths. This is for explaining the concepts. Maths is in risk management. All of the maths in risk management is important for you. Where is this thing? So maybe this one, the ciphers. This is not maths. Is this maths?
Yeah, well, that's kind of basic, but I mean, on like the
Yeah. That's all you need. That's all you need. Yeah, you don't need to do DES or 3DES, or maybe that kind of thing used to be a long time ago. We don't have that anymore because that's just too troublesome. Okay, so now let me just go to that paper. It's a sample paper that was never a paper and will never be a paper. But that doesn't mean these questions cannot come. But I'm saying that what is the structure? I'm just saying structure. This will not be made available to you only through the video, because someone can actually upload it somewhere, as we have found very sadly. When I type in my subject, I find some question papers there that we never created. And this actually does more harm than good to other students. So here, first of all, there are two parts. Part 1 has 10 questions, just 10 multiple choice questions, right? 10 marks. And then part 2 has 4 questions, 10 marks each, 40 marks. So a total of 50 will be down converted to 40, right? So don't read too much on the questions, as I said. This may or may not be relevant. So in short questions, so let's say this is a short question. There can be different parts. So part A, here's a question like firewall rule set analysis. I just talked about the firewall rules a little while ago. And this talks about 5 rules. Actually 6, but this is not tagged. It's implicit. This is just asking you, what does it mean? So this means that this group of IP addresses can talk to any IP addresses for applications that use this particular port, TCP/IP port, and this is allowed, right? So this is just a matter of interpreting correctly a firewall rule, and this has been covered. This is also discussed in your LMS and so on.
Yeah, but like, if you haven't done other subjects, then like, how do most people here? How would they know what like /24? You know, like 24.
You don't have to interpret /24. You can just say this can talk to any computers using this port. You don't have to. It depends on how much you want to talk about. It's just about how much marks. Half a mark for this answer. So 5 of them is 2.5 marks. So this is, I'm just giving an example. This question may never come. This is just an example. Okay. So there could be another question like this, DMZ reachability. And this is not a Marmite diagram, actually. Sorry. Yeah, it used to be a Marmite diagram before. Sorry, this is an actual diagram. So consider the network below and answer the questions that follow. So here you can see there are some LANs, separate sub networks. There is a DMZ of servers. There are 2 people communicating over the internet, one from outside, one from inside. And there is wireless traffic. And then there is the firewalls, right? The 2 firewalls. So the question is, identify which segment is the DMZ. So this is clearly this one. So you can identify this as the DMZ, which is B. And that's it. Can remote VPN users reach server segments directly? Remote ones, they cannot, right? Because they have firewalls to go through. So these are the kind of questions you may come across. Again, don't read too much on these individual questions. This particular one, key strength. Oh, okay. So here is an example of how to. So what mathematical property of a cryptographic key most directly determines the resistance to brute force, right? So very straightforward question. The depth of your answer, by the way, is dependent on the relative allocated marks. So in this case, it's very simple. On the other hand, if there are, let's say, more weight given to this, then you spend more time on this than that. That's one of the things. So here is an example of a cryptographic exercise. You can encrypt it in 2 steps. So this is the plain text. First, use columnar transposition with the key lock. And then whatever is the outcome, you encrypt it again using a scissor shift of +5. Okay? Scissor shift is basically key 3, but here it says use 5, just to confuse the students. But anyway, you just go by a shift of +5, right? Security design principles. There could be a scenario, for example, a scenario like this. They have developers, operations, data analysts, systems, and so on. There's some questions. So referring to the scenario, give one concrete control. That means security control, right? For developers interacting with the ADB, the analytics database. Explain why it fits the least privilege. So it actually specifies. Now, this is an open-ended question, right? So how do you explain, how do you apply least privilege on users accessing analytics database? Simple as that, right? There's another question on separation of duties, design a deployment flow that prevents a single person pushing unviewed. So anyway, this is it's very hypothetical. Don't read too much onto it. This is very much dependent on your understanding of, what is unreviewed code or things like that. So this is not something I would give you an exam question, but the principle still applies. So you may be given a scenario to evaluate and identify the correct or the most relevant concept for that scenario. Okay. There could be another question like imagine there is an e-voting scenario, right? Which of the two among the three of the CIA would you apply and why? You have to give the reason why. If you just say yes or no, if you just give me, let's say, confidential integrity, but don't explain, you'll get part of the mark, but if you're wrong, you're just plain wrong. But if you can justify why you're doing it and it makes sense from the perspective of CIA triad and the scenario, like e-voting, then you'll get better marks for that one. Now, this is an example of an actual question, and you have answered this question multiple times, even for the quiz. So this is something you need to be able to do, calculating CBA, risk analysis, and these kind of things, right? That's it. So you can see that each of the questions dealt with the kind of topics, and that's how this exam will. Typically, this exam used to last about 2 hours. It was a 2-hour question with the same number of questions, but during COVID, because of the problems with access and things like that, we set it to 3 hours. It has been 3 hours ever since. So it should be okay for anyone who is prepared enough. And if you don't know something, there's no point of wasting time, because you cannot come up with these on your own, right? So it all depends on your understanding if you have been exposed to those materials beforehand. So that's
will there be questions? Will there be questions from all 6 modules?
May or may not. It may not cover. Maybe the multiple choice questions may cover some modules, and other things can be covered in the short questions.
Okay. Yeah.
Yeah, but
And
yes, all six modules are examinable.
All right. Okay. And this exam is done on Zoom, or is it done on Zoom?
I don't know. It's Zoom or a proprietary technology. Does anyone know whether it's Zoom?
So you need to install a browser plugin, and then you need to configure and make sure it's up and running.
No, it's not done on Zoom. You just install those extension on the browser, and then the browser can give the permission to monitor you.
Yeah.
By the way, it's not on Zoom. That's true. But your camera will be recording it, and therefore it's like a Zoom in that sense. It's not using the application Zoom.
Okay.
Only they can see you. You can't see them.
Correct. Yeah, you interact with them with some chat window, right?
Yes.
Yeah. Dawn and anyone else, I think it's better to be prepared in the technical aspect of things, not just the content, but how do I take this exam? What do I need to do that test? Please contact support services, send them an email, and they'll be happy to help you out. Okay?
And Doctor, I just ask how many words should I write for one small question, like for that 1 to 2 marks question?
There is no such thing as a limit on word. Use as many words required to answer that question appropriately. I know you're saying 1 mark or 2 mark. Maybe it depends on the question, right? Some question may need 1 sentence, some sentence could be 2 sentences, but there is enough space allocated beforehand. So, I mean, you just press enter and you get new space. So there is no harm in writing more, if that makes sense. But if your writing is too complicated and the correct answer is among one of the many wrong answers, obviously you'll not get good marks on that. So it helps to be precise in your answer, but still, if there are some assumptions you're making, try to clarify the assumptions up front.
Okay.
Okay, thank you.
Will there be a spell checker? My words will be checked when I write?
Spell checker? No, I don't believe
because
so.
when I write, I make mistakes. So, I spelling mistake. Will that be checked? Because all the other places in Notepad and so on, it highlights. Will they be highlighted in this
No,
text?
it's not.
No,
It's
I
just
don't think so.
like Notepad. No, doesn't check.
Okay.
Yeah.
Is that for the short answer part, right? Is that a place you can draw or we can only type?
No, unfortunately, you can't draw. And that's the limitation of the online exam. Very, very unfortunate. I wish you could. And then I could give you some brilliant, kind of things to do, test your drawing skills as well. You can't draw, unfortunately.
When will this video be up, this recorded video be up?
As soon as I get it, it's getting way over long. So this video, yeah, it will take some time to transcribe it automatically at the back end, and probably early morning tomorrow you can get it, or late.
Yeah, and this is the only way we can see the practice exam that you just
Yes, that's
went
correct.
through is by
That's
this
correct.
video.
Yeah. There's no written file. Yeah.
How do you take the exam? You go to the exam, the link, and you click and you go to the exams automatically, the final exam?
The link, does it appear for you? Can anyone check if
Well,
the link?
it said the final exam, and that is, is in the LMS, you get the final exam, and you
The
click
link
on.
will be available when the exam time starts. It gives you half an hour to check your environment, your room. So when it starts, then you can see the link, and then you click on the link.
Okay, but how do I get it? How do I
So
access?
you come here. You come to online supervised exam. On the main page, you click here.
Okay, all right.
And over here, for me it shows, right?
Can you share your screen? Can you share your screen?
Oh, I didn't share. Okay, I didn't share my screen. Okay, just 1 second. So for me, this is how it looks.
Right,
but I'm not too sure if this one appears for you.
All right. Okay.
Same for us as well.
Yeah, you know how I came here? Yeah, I came here from this link here.
Okay.
Yeah. Okay, so that's it. Wish you a very good exam. Just 1 second. Stop recording.